Hi everyone! Welcome to our Precalculus review session for exam 1. So I hope you have already finished the practice exam, and so tonight let's go over all the problems on the practice exam. So if you have any questions, just feel free to unmute and ask me. Okay everybody? Alright, number 1. Use the graph of g of x below to answer the following questions. So part A, write the domain of g using interval notation. Remember, domain is the set of inputs x. So it's kind of, you imagine the sun is over here and then you want to project on the x-axis and you want to find the shadow. Let's look from the left to the right. Look at the left piece. Do you see this point? When you project down, the shadow is right here at -4. And then you project down. Here you project on the x-axis. So you go until here. Do you see at 1 because open circle? It means that point at 1 is missing. So when you project down, we're actually missing the point at 1. And then you continue, project down, and then do you see the number 3? The point is also missing. So we write down the interval notation from the left to the right. The left, we start from -4. And because we want to include the endpoint, we use brackets. Okay? And then we go up to 1. So we don't have the 1. We don't include the endpoint 1. So we use parentheses. Union 1, 2, go. You see we arrive at 3. And we do not include the endpoint. So we put parentheses. So this is the domain. So far so good, everybody? If you can understand part A, could you type A in the chat? How about other students? Okay, good. Yeah, I will need your response because I'm afraid sometimes I go over the problem so quickly, sometimes maybe too slow. So if I ask you questions, yeah, you can answer me, that would be great. Okay, and then part B. We want to find the range. So range is we project on the y-axis, right? So let me erase all this. Okay. So the sun is right here, and we want to project on the y-axis. Okay, let's look at from the bottom to the top. The bottom, the lowest point is the -3, right? If you project on the y-axis, it's -3. And then you can see we go. Here, even though this point is open circle, but actually you have a point on the left, it projects here. So we do not miss this point. And we go up to here. Do you see this point? Get mapped to the 2. So we have the shadow is from -3 is the lowest point to 2. 2 is the highest point. Can you see that from the picture? So our range is from -3. We want to include the -3. So we use brackets. Up to 2. We want to include the 2. So we also use brackets. So this is the range. If you can understand part B, could you type B in the chat? Thank you. Okay, and then let me erase this. Okay. And then part C, we want to find g of -2. Well, this means our x is -2. So you find x is -2, and then you find the graph, what is the y. So look at the picture, x is -2. So on the x-axis, you find -2, and then you look at the point on the graph. Do you see the y coordinate is 1? So g of -2 equals 1. Okay, so make sure you know, okay, -2 is x value or y value. It's x value. So you find the x-axis, find the -2, and then you find the graph, the point on the graph, and you find the y value is 1. Okay, and so if you can understand part C, could you type C in the chat? Thank you. And then find g of 1. So see, the 1 is also inside the function. This is the input x. So x is 1. Ah, look at the picture. When x is 1, do you see both of them are open circle? It means f of 1, g of 1 is not defined. So you can say undefined because the point is missing. We only have open circles. We don't have solid circle. The point is missing. Okay, if you can understand part D, could you type D? Thank you. All right. Yeah, for everybody, if you have questions, just feel free to unmute and ask me. Because if I sit in the classroom, I can look at your face and I can tell whether you can understand or not. But right now, I don't see your face, so I'm not sure if you understand, and I'm not sure if the speed is too fast or too slow for you. So I will ask you questions. But if you have questions, please feel free to unmute and ask me. Okay, part E. Find the values of x such that g of x equals -2. So remember, g of x is actually y. So y is g of x. Y is the output. So we're talking about the output y is -2. Find the corresponding x values. Okay, look at the picture. So we have y is -2. So let me erase the graph. Okay. So y is -2. So the y-axis, you find -2. And then you find, okay, what are the x values? Do you see this point? This point, the x value is -1. And then you might ask, how about this point and this point? Well, because they are open circles, it means those points are missing. So they're missing. We don't count them. We only count the number when x is -1. Okay? So here we have the x is -1. If you can understand part E, could you type E in the chat? Thank you. And then part F. Determine the interval on which the function is increasing and on which the function is decreasing. Oh, I should put g of x, okay, because the function is g. All right, then we look at the picture from the left to the right, okay? So start from the -4 and 2. And do you see here is decreasing? And then here is also decreasing until we reach this point. This point is when x is 0. So when we are asked to find the intervals, they're interval of x. Okay, so from -4 to x is 0, we have the function is decreasing. So we can say f is decreasing on the interval from -4 to 0. You're talking about interval, so those are x values. Okay? And you don't need to include the endpoint. So when they ask you find the intervals of increasing or decreasing, you don't need to consider the endpoints. Okay? And then next piece, we keep going. You see from 0 to 1, so when x is 0 to 1, our function is increasing. So you can say f is increasing on, and this interval x is 0 to 1. Okay, so x values, they're interval. And then next piece, do you see from x is 0 to x is 3, our function is decreasing. So from x is 1 to x is 3, the function is decreasing. So you look at the picture from the left to the right, and then you figure out the x interval where the function is increasing or decreasing. Typical mistake is sometimes students put the point there. Don't put the point here. You mean x interval, the x values. If you can understand part F, could you type F in the chat? Thank you. Okay, next problem. Find all the relative maximum and minimum values and the x values at which each occurs. Okay, so we look at the picture. We start with the left endpoint. Do you see this is a solid circle? So the point is there. The point is right there. Okay, so then you can see this is a local maximum because it's the highest point for all the x near it. So we get relative maximum, and you can use a coordinate notation. Okay, so we have the x is that point, x is minus 4, and the y value is 2. So when x is minus 4, our relative maximum value is 2. So part F and part G, everybody see the difference. Part F, we were talking about the x values. So they are interval. Okay? But part G, we're talking about the points. So they are order pair x and y. Okay, coordinates. So even though it's still parentheses of two numbers, you put comma in between, but they mean different things. Okay, so that's the relative maximum. And then we continue. You see this point? This is not max or nor min, okay? So we keep going. And okay, we find this point. It's the lowest point for the x near it. So this is a local minimum. And then the x coordinate is 0. The y coordinate is -3. So we can say relative minimum, the x is 0, and the y is -3. Okay, everybody? Keep going. And then, oh, look at this number. Because it's open circle, we do not have a relative maximum. If you have some point, like some graph like this, then this will be a relative maximum. Or if you have some graph like this, then this will be a relative maximum. Okay? But because our point is open circle, the point is missing, we do not have a relative maximum there. And then we keep going. Oh, do you see here? Because the point is also missing, we don't have relative minimum. So therefore, the only relative maximum is at the point -4, 2. And then the only relative minimum is at the point 0, -3. So this problem, you gotta be careful. You look at the open circle and solid circle. Open circles means the point is missing. Solid circle means the point is included there. Okay? So if you understand all the parts of problem 1? Could you type 1 in the chat? Thank you. Okay, let's continue. So I have 3 students answer my questions. How about the other students? Are you able to follow? So I have 6 students total. How about other students? Are you doing okay? Or you're not able to type in the chat? I'm just making sure. Okay. All right. Problem number 2. Starting with the parent function. Graph this function in the grid below. Be sure to describe the sequence of transformations with the correct order and the correct formula at each step. Okay, so this problem, remember our parent function? So I give you the review formula sheets, right? And we have 5 parent functions. They are x squares. Move your hands. X square, what does it look like? And what are the key points of x squared? Do you remember? Okay, let me find the parent function. Okay, so I got it here. This is the parent function. Okay, so x squared, we care about 5 key points, 0, 0, 1, 1, and 2, 4. Minus 1, 1, minus 2, and 4. X cubed, 5 key points, 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. And then square root of x, 3 key points, 0, 0, 1, 1, 4, 2. Cube root of x, 5 key points, 0, 0, 1, 1, 8, 2, and minus 1, minus 1, minus 8, minus 2. And then absolute value of x, 0, 0, 1, 1, and negative 1, 1. We have 3 key points. So we have 5 parent functions. Make sure you remember them, okay? So in the exam, so the practice exam, I asked you x cubed. But in the actual exam, it could be x squared, x cubed, square root, cube root, or absolute value of x. So be prepared for all of them. Okay? So now because it's cubed, so you start with the parent function x cubed. X cubed, we have 5 key points. They are 0, 0, 1, 1, and 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here. And minus 1, minus 1. Minus 2, minus 8. 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. And we connect those points smoothly. Oops. Okay, let me make it look nicer. Yes. So connect them smoothly. This is the parent function. And we follow the order of transformations. What are they? Remember? Math exercise, math dance, shift left and right. Okay, left is plus c, right is x minus c. And then we reflect about the y-axis. Do you see a minus sign in front of x? And then the third one reflects about the x-axis. Do you see the minus sign in front of the y, like everything? And then vertical stretch by a factor of c. Do you see a number multiplied by the whole thing? And then the last one shift up and down. So do you see everything plus or minus a number? So here, left or right? Okay, you see everybody? X plus 3. So we start with the parent function. Change x by x plus 3. And left plus right minus. So shift left 3 units. Okay, everybody? So we have 5 key points. Let's look at this. 1, 2, 3. Shift left 3 units. Then we're at minus 5. 1, 2, 3, 4, 5. minus 5, and minus 8 here. So with this point. And then this key point 1, 2, 3. So shift here, it becomes minus 4 and minus 1. And then 0, 0 shift left 3 units. We're at minus 3, 0. And then the 1, 1 shift left 3 units. We're at minus 2, 1. And then last point, you shift left 3 units. You're at minus 1, 8. And then you connect them. So this is the graph. So far, so good, everybody. Maybe you want to make the graph more smooth. So try to make the graph more smooth. Okay. So this is how it looks like. So every step, you want to write down the formula, the transformations, and the graph. Okay, and then next one. You see, next one reflect about the y-axis. Do you see a minus sign in front of x? Yes. See, we see a minus sign in front of x. So put a minus sign in front of x. And this is reflect over the y-axis. And now y-axis. Look at this point, mirror image. So we get this point is 1, 8. And this point mirror image. We're at the point 2, 1. This point mirror image. So we're at the point 3, 0. This point mirror image. Okay, where is it? Okay, then it's at the point 4, negative 1. And this point mirror image, let's see. So it's 5, negative 8. And then we connect all the points smoothly. Okay, this is the picture. So far, so good, everybody. Thank you. Alright, so we keep going. Next, we check, do we have reflection or about the x-axis? Do you see a minus sign in front of everything? See here, we don't have a minus sign in front of everything, so we don't have reflection over the x-axis. But we do have a 2 multiplied by everything. So next step, the formula is 2 times negative x plus 3 cubed. And this is vertical stretch by a factor of 2. Okay, and remember the x remain the same, and then the y coordinates we multiply by 2. Okay, so x remain the same, the y coordinate multiplied by 2. Okay, look at the first point. The first point is 1, 8. When you multiply the 8 by 2, you get 1, 16, which is very up there outside of the paper. Okay, so maybe let's draw the next point. The next point is 2, 1. Okay, 2, 1. The 1 multiplied by 2, you get 2, 2. So this is 2, 2. And then next point, 3, 0. 3, 0. When you multiply the y coordinate by 2, it gives 3, 0. A typical mistake is sometimes students also multiply the x coordinate by 2. No, x coordinate remain the same. Okay, and then next point is 4 minus 1. So you multiply the minus 1 by 2, you get 4, negative 2. So 4, negative 2. And then the last number is 5 minus 8. when you multiply by minus 8 by 2, it becomes minus 16. It will be, yeah, so below. Okay, so then you can connect those points together. Okay, so this is the picture. So you can see right now, you only have 3 key points in the picture. That's okay because the 116 is so large, it's outside of the grid. That's okay. Then you only need to put those 3 key points here. Okay, and then last one, shift up and down. Do we have shift up and down? Do we have everything plus or minus a number? Yes, minus 1. So the last step is minus 1. So shift down 1 unit. We have 3 key points now. The 2 shift down by 1, it becomes 2, 1. The 3 0 shift down by 1, it becomes 3 negative 1. And then the 4 negative 2 shift down by 1, it becomes 4, oops, negative 3. Okay, everybody? So, and then we connect them together. So this is the graph. And we finish the graph of this problem. If you can understand this example, could you type 2 in the chat? Good. So you can make up some problem to practice. Like for example, how about you can try y equals minus 4 and then square root of minus 2x plus 1 plus 5, something like this. Or you can try how about minus 2 and then absolute value of x minus 4 and then minus 3. Yeah, I just make up some problem you guys practice. Okay, and maybe how about 3 x minus 1 square plus 6, something like that. Or you can do minus 4 and which one will I even make? Oh, key roots. Okay, so key root of x plus 5 and how about plus 2, something like this. Okay, so this is key root. So sometimes you're not sure the q is like with the 4 or with the radical, and you can always raise your hand and ask me in the exam. Okay. Alright, so yeah, you can make up more problems to practice. Okay, problem 3. Find the equation of the line parallel to this line. So let's say this line is line number 1. We want to find the line number 2 that is parallel to line number 1 and passing through the point 2, negative 5. And write your final answer in the slope-intercept form. Okay, line number 1. We need to figure out the slope. So you want to find the slope-intercept form, which means you want to solve for y. Okay, solve for y. So subtract 6x on both sides. We get minus 8y equals negative 6x plus 5. And then solve for y, right? And both sides divided by minus 8. On your left hand side, minus 8 cancel. On your right hand side, you get minus 6x over minus 8. And then you have 5 over minus 8 when you split them. But you can move the minus from the denominator to be in front of the fraction. And you can simplify. Do you see the minus cancel? And 6 and 8 has a common factor 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So we get this. This is the slope-intercept form. The slope is this number, the coefficient of x. So you can see m1 is 3 over 4. And you see, so this is the slope, and the y-intercept is 0, comma, negative 5 over 8. So this is the slope-intercept form. So we just need to find the slope, because we know the line 2 is parallel to the line 1. Remember, two lines are parallel if they have the same slope. So m2 equals m1 equals 3 over 4. So we know the slope of the second line is 3 over 4. And we also know that it passed through the point 2, comma, negative 5. Then you can use the point slope form. That's why I said you need to make sure you are familiar with all this formula. Point slope form, y minus the y coordinate of the point equals the slope times x minus the x coordinate of the point. And therefore, y minus the y coordinate of the point is negative 5 equals the slope. Slope is 3 over 4. And x minus the x coordinate of the point. So far, so good, everybody? So you get y minus negative become plus 5 equals distribute. We get 3 over 4x minus 3 over 4 times 2. Do you see the 2 and the 4 cancel? We have the 2 left. And we want to solve for y. So we want to subtract 5 on both sides. So on your left hand side, you get y equals 3 over 4x. And here we minus 3 half and minus 5. But 5, if you want to combine those two terms, you want to look at the common denominator, which is 2. So it's like subtract 5 times 2 over 2. It's like we subtract 3 half and we subtract 10 over 2. It's like you put the minus sign in front and the common denominator is the 2. And then you're doing 3 plus 10. Okay, when you move the minus in front, it's like you factor out the negative. That's why the second term, you change from minus to plus 10. So finally, our answer is 3 over 4x. And then the constant term is minus 3 plus 10 is 13 over 2. So this is the answer. So if you can understand this part, could you type 3 in the chat? Thank you. Alright, so let's keep going. Part B. So part B and part A very, very similar. Except part B, we're looking for the line perpendicular to it. Okay? But the line number 1 is still the same thing. So you still have your line number 1, the slope is 3 over 4, right? We can use from the previous step. M1 is 3 over 4. But because line 1 and line 2, they're perpendicular, then M2 is negative reciprocal of M1. Negative reciprocal of 3 over 4 is negative 4 over 3. Right, everybody? And it also passed through the same point. So we use the point slope form. Okay, so point slope form, y minus negative 5. But now the slope is negative 4/3. I'm copying this what we had last steps, but we just changed the slope. and then times x minus 2. So far, so good, everybody? Minus -5 become plus 5. And then we distribute. So -4 x. Negative become positive. 4 times 2 is 8. Right? And we want to solve for y. So we subtract 5 on both sides. We get y equals -4 x. Okay, here. Plus 8/3 minus 5. 5, you multiply by 3 and divide it by 3. Because when you add fraction, you have to have a common denominator, right? So this is like 8/3 minus 15/3. So it's like 8 minus 15. So final answer, y equals -4 x. 8 minus 15 is minus 7 thirds. Okay, so this is the final answer. So if you can understand part B, could you type B in the chat? Thank you. Good. Okay, so we keep going. Okay, problem 4. So we have two functions. We want to find the composite function and we want to find its domain. So f composite g is f of g of x. So you evaluate from the inside to the outside. What's g of x? See, look at the problem. G of x is 3x squared minus 5x. Okay, everybody? And then you want to plug in the f. So f of this means whenever you see the x in the formula of f, replace x by 3x squared minus 5x. That's why you get 5, and then square roots. The x, replace x by 3x squared minus 5x. See, you replace x by this giant expression. And then you still have minus 2. Okay, everybody? And after you write this out, you realize, what if the square root is on top? Oh, if your square root of is on top, like 5 square root of x over 2, x minus 2, then you put then after you plug the x, so you replace x, so you kind of erase the x and you replace it by this whole thing. When your square root is on top. Yeah, yes. It's whenever you see x. So maybe your problem, maybe your f, you have more than one place has x. For example, maybe you have like 5x plus 2 all over like square root of like x minus 2, something like this. Then you're doing 5, and then you plug in this new thing here. So 5 times 3x squared minus 5x, and you plus 2, and then all over the x. See the x, then you plug in this thing again, minus 2. If you have like more x, then you just replace the x by this giant term, like 3x squared minus 5x. So it depends on how many x in the formula of f. It's whenever you see x, you replace x by 3x squared minus 5x. Is that okay? Good. So let's keep going. And actually you realize because here we don't need the parentheses. sometimes you gotta be careful because if you have like minus something, this parentheses, you must include that. Or sometimes you have this guy square, you must include the parentheses. But in this case, it's okay to not include the parentheses. So be careful. Parentheses is like our baby. Don't forget the baby. So here we remember the baby, and then we realize, okay, in this case, it's okay to remove the parentheses. All right, now let's see. Okay, this is the composite function, and we want to find the domain. Okay, domain part is here. Two things we care. Do you see a square root? If you see a square root, we need the things inside the square root to be greater or equal to 0. If you see a fraction, then you need the denominator is not 0. Okay, that's why here we see square roots, so we need the things inside the square root to be greater or equal to 0. This is because of the square root. And because also this guy is in the denominator, we need the things inside the denominator not equal to 0. You see, it's greater or equal to 0, but it's not equal to 0. You end up getting this guy is greater than 0. Okay? So this is an inequality. How do we solve inequality? We factor, right? We move all the terms to the left-hand side and we factor. Okay, let's see how can we factor it. So factor it, we get 3x squared factors x 3x and x minus 2. It could be 1 and minus 2. It could be minus 1 and 2. But because the middle term is minus 5, I would say we put minus 2 here and put plus 1 here. When you multiply the outside, you get negative 6x. When you multiply the inside, you get x. So when you add them together, you get minus 5x. So this is the correct factoring. Okay, everybody? And then we keep going. So we keep going. We have the factoring and we find the critical number. The critical number is you set each factor equal to 0. And solve for x. See, we subtract 1 on both sides and we divide it by 3. We get minus 1/3. Here we add 2 on both sides. We get x is 2. Real number line and the critical numbers negative 1/3 and 2. And then we look at, because it's greater than, so we put open circle. Open circle. If you see greater than or equal, then you put solid circle on the critical numbers. Okay? And then you look at the leading coefficient. What's the leading coefficient? If you know the answer, type it in the chat. Let me see in the chat. The leading coefficient is the coefficient of the highest term, right? So leading coefficient is 3. And do you see it's positive? So we start with the right upper corner. Okay? And when we meet the number 2, you look at the multiplicity. Do you see here the multiplicity is 1, which is odd? So we cross. And when we meet the number negative 1/3, it corresponds to the factor of 3x plus 1. And the multiplicity is 1, is also odd. So we cross. Therefore, this is above the x-axis, positive, below, negative, above, positive, and we are looking for greater equal to 0. So greater equal to 0 is the positive. So therefore, it's from minus infinity to negative 1/3. Union 2 to infinity. So this is the domain. If you can understand this problem, could you type 4 in the chat? Thank you. So we keep going. Okay, find all the real solutions for this equation. So we have absolute values. And remember, this is in section 1.6. If the variable is only inside the absolute value, then you isolate the absolute value, and then you set that thing equals a plus or minus a constant, right? But here, if you see the variable is both inside the absolute value and outside of the absolute value, this is how you solve it. You put a line there on your left part, you kind of just ignore the absolute value. So you get x minus 15 equals x squared minus 15x. And then the second part is you replace the absolute value by minus parentheses. So minus parentheses of x minus 15. That's inside the absolute value. Equals x squared minus 15x. Okay. Now you have quadratic equation. How do you solve quadratic equation? Move all the terms on one side. Okay, so here we move the x to the other side, so we subtract x. Move the 15 to the other side, we add 15. Then your left hand side is 0. Your right hand side, x squared minus 15x minus x is minus 16x. And then plus 15. Okay, how do we solve quadratic equation? Two methods, either factoring or use the quadratic formula. So I usually try factoring first. If I'm not able to factor, then I use the quadratic formula. Okay, so xx 15. Yeah, 15. If you put minus 15 and minus 1, you multiply the outside, you get minus x. And you multiply the inside, you get minus 15x. You add them together, you get minus 16x. So this is the correct factoring. Okay, the product of two factors equal to 0. It means the first factor equal to 0, or the second factor equal to 0. And we solve for x. So add 15 on both sides. We get x is 15. Here we add 1 on both sides. We get x equals 1. So we have two roots. By the way, the problem in the exam might not be such nice numbers. Okay? Because if I randomly just make up a problem, usually the number is not so nice. I think this problem I took it from your textbook. That's why the number is so nice. But on the exam, the number are not so nice. Okay? So if you get something weird, that's possible. So on the exam, yeah, just show all your work. Even though sometimes you might make mistakes, but you get partial credits. So show all your work in the exam. Okay, on the right hand side, you see, I can both sides add this drawing term. So both sides add x minus 15. Okay, because some of you might like distribute the minus, but even though you distribute the minus, you still need to move it to the other side. So you can like consider this is the whole term, and you add this thing on both sides. Then you can cancel it. So on your right hand side, you have x squared minus 15x plus x is minus 14x. And you still have the minus 15. And are you able to factor it? Let's see if we can factor it. So x, 15. Oh, you see, minus 15 and plus 1. It will work. So you get x times 1 is x. Minus 15 times x is minus 15x. When you add x, it becomes minus 14x. So this example is, the number are so nice, you can factor on both sides. But in the exams, maybe on one side you can factor it, the other side you have to use quadratic formula. Okay. So here we set each factor equal to 0. And we solve for x. So x is 15. And here we subtract 1, or x is minus 1. Okay. And don't forget this problem, you need to check your work, because not all the answers are solutions. So we plug in, so let x equals to 15. You plug in, you get 15 minus 15. Is it equal to 15 squared minus 15 times x? X is 15. Yeah, you get 0. And the right hand side, 15 squared is 15 times 15, so they cancel. So check. 15 is a solution. How about 1? You plug in 1. 1 minus 15. Is it equal to 1 squared minus 15 times 1? On your left hand side, negative 14. But absolute value, it make it positive 14. But the right hand side, you still have 1 minus 15, which is negative 14. They're not the same. So 1 is not a solution. And how about on the right? Oh, do you see 15 is, we already have 15 as a solution. So don't need to check that. Okay? But the something new is the minus 1 is something new. So we plug in x is minus 1. And minus 1 minus 15. Minus 1 squared minus 15 times minus 1. Minus 1 minus 15 is minus 16. But absolute value of minus 16 is 16. On the right hand side, minus 1 squared is 1. Minus minus become plus. Oh, you see 1 plus 15 is actually 16. Yes, x equals minus 1 is a solution. So the solutions are the 15 and the minus 1. So this is the final answer. So far so good, everybody? If you can understand number 5, part A, could you type 5 in the chat? Thank you so much. Okay. So part B, find all the real solutions of this equation. So this problem is kind of, I would say, easy than the problem on the actual exam. So if you remember this file where I put like more examples from your notes. Okay, so it's loading. So I put more examples here besides the practice exam. Okay, so yes. So I want you to be able to do here our practice exam problem x and x plus 2. They're still easy. So I hope you can do something like harder, like x plus 3 or x minus 3, or it could be some other factors. Maybe it's 2x plus 3 and 4x minus 1, something like that. Okay, so be prepared. Like make up some problem to practice. Okay, so For example, I'm just making up some problem. Maybe you can try a 4 over 2x minus 3 minus 7, and maybe 4x plus 1 equals to 11 over 2x minus 3, 4x plus 1. Yeah, so try this one. Okay, so make the problem harder. Okay. So do you want to do the easier problem or do the harder problem with me? So everybody either type harder or easier. The easier problem, I already have the solution for you. But the harder problem, do you want to try it? Do the easier one? Everybody? But I'm afraid the exam problem will be harder than this easier one. Do the harder one? Okay, because the easier one, you have solution on the website. Okay, so yeah, do the harder one. Your exam more like the harder one. Okay, because I just make a problem, so I don't guarantee we will have a solution for it. But let's try to solve the problem and see what happens. Okay, so first of all, you want to find the least common denominator. The least common denominator you can see here are 2x minus 3 and 4x plus 1. This is the least common denominator. And in order to find the domain, you need the denominator not equal to 0. So you have 2x minus 3 not equal to 0. And 4x plus 1 not equal to 0. And then you solve for x. So we add 3 on both sides. You get 2x not equal to 3. And both sides divided by 2. So x not equal to 3/2. On the other side, subtract 1 on both sides. You get 4x equals minus 1. And x is both sides divided by 4. Not equal. So x not equal to minus 1 over 4. So those are two numbers outside of the domain. Okay, now we want to have all the fractions have the least common denominator. So therefore, the first fraction, in order to get the least common denominator, we multiply by 4x plus 1. That's the first term. Second term, 7 over 4x plus 1. And here, in order to get the least common denominator, we multiply by 2x minus 3. And that equals the right hand side 11 over 2x minus 3 times 4x plus 1. So far, so good, everybody? And now, see, both sides, you have the least common denominator. So you can both sides multiply by the least common denominator to get rid of all the denominators. So on your left hand side, when you get rid of all the denominators, you get 4 times 4x plus 1 minus 7 times 2x minus 3. And on your right hand side, you multiply by the least common denominator. So that term is gone. Okay? And now you see, oh, let's distribute. So we distribute, we get 4 times 4 is 16x. 4 times 1 is 4. Minus 7 times 2x is minus 14x. Minus 7 times minus 3 is positive 21. And that equals 11. So far, so good, everybody. Oh, we can combine the like terms. So 16 minus 14 is 2x. And 4 plus 21 is 25. We want to solve for x. So subtract 25. 11 minus 25 is negative 14, right? 25 minus 11 is 14, yeah. And both sides divided by 2, we get x equals minus 7. It's actually a good number. I just make up the problem randomly, and we get a nice number. And you check, do you see this number is in the domain? Yeah, it's not equal to 3/2, it's not equal to minus 1/4. So this is a solution. And then we finish this problem. So make sure you write down the least common denominator and you find the domain. And then for each fraction, you multiply by appropriate factors so you get the least common denominator. After you make sure all the terms, so terms are separated by plus or minus, okay? So this is one term, this is one term. You make sure all the terms have the least common denominator. Then you can both sides multiply by the least common denominator to clear all the denominators. And then you just look at the numerators. And you distribute, get rid of the parentheses, combine the like terms, and you solve for x. If you can understand this problem, could you type B in the chat? Thank you. And let's also look at the, let me make this bigger. Okay. The one on your practice exam is very similar. But you see the least common denominator, we have x and x plus 2. You set the least common denominator not equal to 0. So each factor not equal to 0, you solve for x. So x is not equal to 0 and x not equal to minus 2. Okay? And then, so I did it differently. I didn't, I multiplied the LCD right away to get rid of the denominators. You can do it this way. You can multiply by appropriate factor to get the least common denominator first, then multiply it by multiply this on both sides. It will be the same answer. Okay, so this is what you get. And here, this problem, when you distribute, do you see you have an x squared? So this becomes a quadratic equation. So, and I realized the x cancel. You only have x squared on one side and a constant term on the other side. In this case, you can just take square root. And when you take square root, don't forget you get plus or minus square root. And you check your answers, they are in the domain. So both of the numbers are solutions. So this is your practice exam problem. So far, so good, everybody? Okay. All right. So let's keep going. Okay. All right. Okay. Okay. So move this away. Okay. Next. Let's see. Okay. All right. We continue. Next problem. Okay, inequality with absolute value. So how do we do that? All right, let's see. Okay. All right. In this case, we isolate the absolute value. Okay, we isolate the absolute value. And then you want to break it. Remember how you break it? So where am I here? Oh, here. So I think is it here? Yes. This is how you break it. This is small inside minus a and a. This is big outside. So outside means either less than minus a or greater than a. So therefore, let's isolate it. Okay, so we want to get rid of the 4 and minus 3. But what do we do first? We move the 3 first, right? So we add 3 on both sides. Then we get 4, absolute value of x plus 12 greater than 17 plus 3 is 20. And then we want to get rid of the 4. So both sides divided by 4. Remember when you work with inequality, when you multiply or divide it by a positive number, you don't change the inequality sign. But when you multiply or divide it by a negative number, you flip it, right? So here 4 is positive. We don't need to change the inequality sign. Okay, you see we isolate the absolute value. Now, how do you break it? See, greater than something. Distance is big. Big? Outside. Outside what? Minus 5 and 5. And because this does not have the equal sign, you put open circle. So open circle. Oh, sorry. Here. Oops, not here. Here. Okay. Maybe I need to save it. Okay, open circle. You see the picture? You get x plus 12 is less than, alright, not equal, open circle, is either less than negative 5 or the x plus 12 is greater than 5. Don't just put the x, it's whatever inside the absolute value, you put the whole thing here. So less than minus 5 or greater than 5. So this is big outside. This is outside means. And then when you solve for x, we subtract 12. X less than negative 5 minus 12 is minus 17. Here, subtract 12. 5 minus 12 is negative 7. Okay, so you can see is less than minus 17 or greater than minus 7. So from minus infinity to minus 17, open, we don't include the endpoints, minus 7 to infinity. So this is the answer. So this is how we solve inequality with absolute value. If you can understand this, could you type 6 in the chats? Thank you. So make sure you draw the inequality and you write down your answer using interval notation. Otherwise, some points will be off. So that's why I show you the solution, and you can see how detailed, like how many steps I show you on the solution. So I give points every step. Okay, so here, evaluate and simplify. So complex numbers. So when you add or subtract fractions with complex numbers, you want to get rid of the I in the denominator first. So look at the first fraction, 3 minus 4i, 5 minus 2i. We want to get rid of the I in the denominator. So you multiply by the conjugate of the denominator. So we multiply by, okay, conjugate. So 5 and 2i, same, but the middle sign, it was minus, now you put plus. And you multiply the same thing on top and bottom. So you're not changing the problem. Okay, we cannot just make up the problem and change it. We want to make it equal. Equal means, well, when you multiply and divide it by a number, is the same as you multiply by 1. So you're equal to the old quantity, right? We're not changing it. They're still equal. And okay, the second one, 2 minus 7i, 4 plus I, and you multiply by the conjugate of the denominator, 4 minus I. Okay, and now this should be, so 5 times 3, 15. 3 times 2i, 6i. Minus 4i times 5, minus 20i. Minus 4i times 2i is minus 8i squared. And 5 times 5, 25. 5 times 2i is 10i. Oh, by the way, the denominator, you remember a minus b times a plus b is a squared minus b squared. So you actually get a squared, 5 squared is 25, minus b squared, which is 2i squared. Yeah, we actually can do that. And this side, 2 times 4, 8. 2 times minus I, minus 2i. 7 minus 7i times 4 is minus 28i. Minus 7i times minus I is positive 7i squared. Denominator, a plus b times a minus b is a squared. 4 squared is 16 minus b squared, I squared. Okay, let's see. I squared is minus 1. So minus a times minus 1 is actually like plus 8. 15 plus 8 is... What's 15 plus 8? Type your answer in the chat. Yes, 23. Okay, and then 6 minus 20 is minus 14i. Okay. And here, you see when you distribute the square, you get 4i squared. And I squared is minus 1. So you get minus 4 times minus 1 is actually plus 4. So it becomes plus 4. And then on the right, I squared is minus 1. So you have 8 minus 7 is 1. 8 minus 7 is 1. Minus 2i minus 28i is minus 30i. And 16i squared is minus 1, so it can become plus 1. So let's see. 23 minus 14i over 25 plus 4 is 29. And minus 1 minus 30i over 17. Okay, now you break them. So 23 over 29 minus 14 over 29i minus 1 over 17. And then when you distribute, minus become plus 30 over 17i. Okay, you add the content together. Oh, well, this is a big number, isn't it? Okay, so common denominator, I would say 29 times 17. And then you are using the 23 multiplied by 17. And then you minus the 1 times 29. Is everybody okay with that? Because when we add or subtract fraction, you have to get a common denominator. The common denominator is 29 times 17. That's why this guy you multiply by 17, and this guy you multiply by 29. So your numerator is now 23 times 17 minus 1 times 29. Is that okay, everybody? Yes, if yes, could you type yes? Because the number are harder. I want to make sure you follow. Thank you. And next, the one with the I. Let's see. So it's minus. Still, the common denominator is 29 times 17, but your 14 you multiply by 17, right? I. And then here you get what? The 17 and 30 we multiply by 29. I. Okay, I need the calculator. Can I find my calculators here? Okay, so I can type decimal. I use this calculator. If you have your calculator, type it. Oh, I just need a regular calculator. So scientific calculator. What? Oh, here. Okay, so 17 times 29, 493. So 493 and 23 times 17 minus 29. So 23 times 17 minus 29. 362. Yes. Thank you. So 362 and minus. Oh, okay. This number. Okay. I can do the denominator the same for 93, but your numerator is 30 times 29 minus 14 times 7. So 30 times 29 minus 17 times what? 14. Oh, 632. So this is our answer. Yeah, it's big. Okay, so this is the answer. So yeah, sometimes some problems when I make it the problem, you might get hard numbers at the end. That's possible. Okay, if you can understand number 7, could you type 7 in the chat? Thank you. Okay. All right. So solving quadratic equation. Yeah. So we have done many examples like this, right? And you first try factoring. If factoring does not work, then you use the quadratic formula. So here, if you try factoring, you put 3x and x. 5 is 1 and 5. But minus 15, you see, if you put 5 here and 1 here, it won't give you minus 15 in the middle. And if you put minus and minus, you get minus 15x and minus x, it won't give you minus 10x in the middle. So in this case, no factoring method. Use quadratic formula. What's the quadratic formula? See, b x is negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so use this. A is 3, b is minus 10, c is 5. So x equals negative b. B is minus 10, negative 10 become positive 10. Plus or minus b squared. So minus 10 squared. Don't forget the parentheses. Minus 4, a is 3. C is 5. All over 2a. So 10 plus or minus. Be careful when the negative square become positive. So you get 100 minus 4 times 5 is 20 times 3 is 60. 2 times 3 is 6. Oh, 100 minus 60 is 40. 40 is like 4 times 10. But when you do square roots, square root of 4 is 2. So 2 and square root of 10 divided by 6. You can factor out the 2. We get 5 plus or minus square root of 10 all over 6. You have to make sure you have the product multiplication. Then you can cancel. Okay, you cannot cancel here. No, it's addition or subtraction. You cannot just cancel one term. You have to factor a common factor in front. Make sure you have multiplication. Then you can cancel. So this is 5 plus or minus square root of 10 over 3. So you can leave your answer like this, or you can type into your calculator and get some decimals. So if you can understand number 8, could you type 8 in the chat? Thank you. Okay, so we keep going. Okay. Problem 9. Write the quadratic function in the standard form and sketch its graph. Identify your vertex and axis of symmetry. So I just finished grading your quiz. I already posted quiz solution and quiz mistakes on the website. Tomorrow we will go over your quiz. Okay. So yeah, this problem is similar to the quiz, right? You have your general form. Your A is 3. Your B is negative 12. And your C is 7. And you want to change it in terms of the standard form. And you want to sketch its graph. Standard form H is, make sure you remember the formula. This is the formula. Standard form or vertex form, A times x minus h squared plus k. Vertex is h comma k. Axis of symmetry is x equals h. Don't just give me a number. It's an equation. It's a line. It's a horizontal line. So x equals. Don't forget that. Otherwise, some points will be taken off in the exam. So h is negative b over 2a. B is negative 12. 2a. A is 3. Negative cancel. 12 over 6 is 2. You see h is 2. And then k is f of h. F of 2. That means whenever you see x in the expression, the formula, replace x by 2. So 3x squared, x is 2, 2 squared, minus 12x, x is 2, plus 7. And 2 squared is 4, 3 times 4, 12, 12 times 2, 24, plus 7. 12 minus 24 is minus 12, plus 7 is minus 5. So minus 5, that's the k. Now you know the vertex is hk. H is 2, k is minus 5. And standard form. Many of you didn't read the problem carefully. I say standard form. Many of you forgot to write down the standard form. Standard form is y equals a x minus h squared plus k. Now you plug in. Your a is 3. Your h is 2. Your k is negative 5. Write down your standard form. So read the problem carefully. Yes? See, we get the vertex, we get the standard form. We also need the axis. It's a line. So x equals to h. H is 2. Give me a line. Give me an equation, not just the number 2. Okay? Now you can sketch the graph. So you don't have to draw you don't have to find the x-intercept. The problem didn't ask you to find the x-intercept. So you don't need to do that. So 2, -5. So 2 here, -5 here. This is the vertex. Our A is 3, positive, so opens up. So your parabola looks like this. So this is what I require you to do in the exam. Okay, read the problem carefully, standard form, the vertex and axis, and then sketch the picture. The picture just need to identify the vertex and tell me it's open up or open down. It does not need to be very accurate, so you don't have to find the x-intercept. Oh, but actually here, from this picture, from the general form, you can know more. Remember the A is the shape of the parabola. It talk about open up or open down, or it's very skinny or it's very flat. It talk about the shape. And then the 7 is actually the y-intercept. So the y-intercept is 7. So we know it passed through the 7. Okay, this one we can see easily from the general form. So we know it passed through here. So it looks like this. Okay. Let me make it look better. So it's like symmetry. Okay, this is better. So this is the parabola. So far, so good, everybody? If you can understand problem 9, could you type 9 in the chat? Thank you. Okay, so keep going. Part B. Write the standard form of the equation of the parabola that has vertex 4, -1 and passes through -1, 3 and sketch its graph. So vertex form. Y equals ax minus h squared plus k. It tells you the vertex is 4 -1. So your h is 4. Your k is -1. See, you still have the a you want to find. So it tells you the information it passed through the points -1 and 3. So this information can help us to find the a. You plug in x is -1, and you plug in y is 3 into this equation. Y is 3. A is the unknown. We want to find what a is. X is -1. Okay, here they are numbers. Okay, don't use the complete square rule. A minus b squared is a squared plus minus 2ab plus b squared. Don't use that. -1 minus 4 is -5. Okay, just evaluate, calculate it from the inside to the outside. -5, and then you square it, it becomes 25. And then you subtract 1. Is that okay, everybody? Yeah, calculate it -5, but parentheses square become positive 25. And you want to solve for a. So add 1 on both sides. 4 equals a times 25. So both sides divided by 25. A equals 4/25. So our answer, write down the standard form. Okay, write down the standard form. So your A is 4/25 and x minus 4 squared minus 1. This is the standard form. Or you can say the vertex form. Sketch is graph. Look at the graph. It has the vertex 4, -1. And it passed through -1, 3. Okay, and you know A is positive, so opens up. Okay, so we open up and it passed through that point. So this is the parabola. If you can understand part B, Could you type B in the chat? Thank you. Okay, let's keep going. So problem 10. Sketch the graph and be sure you show x-intercepts and y-intercepts and the end behavior. This is like your quiz, right? So you start with set each factor equal to 0. So x minus 7 is 0. 2x plus 1 is 0. 3x minus 2 is 0. And you solve for x. So S7 on both sides. You get x is 7. Subtract 1. So 2x is minus 1. And divide it by 2. So x is minus 1/2. Here add 2. 3x is 2 divided by 3. So x is 2/3. So you can say x-intercept, they are points. So x-coordinate is 7, y-coordinate always 0. X-coordinate minus 1/2, y-coordinate 0. X-coordinate 2/3, y-coordinate 0. So we have the x-intercept. So far, so good, everybody. We set each factor equals 0 and we find the x-intercepts. And then to find the y-intercept, we plug in the x is 0. That means you look at all the, so think about it when x is 0. So the x is all gone. So just get rid of x. You get 5 times negative 7 squared. X is 0, so 2x is gone. You have 1 squared. X is 0, 3x is gone. Negative 2 to the 7. You see all these numbers are actually the constants in each factors. Okay, so collect the constant terms. And don't forget the power. And here we actually need to compute what this number is. But you can see this is 5. Minus square become positive. 7 square is 49. 1 square is 1. And minus, oh, you see minus 1 to the 7 is still minus 1. And then 2 to the 7 is 128. So 2 squared, 4. 2 cubed, 8. 2 to the 4th, 16. 2 to the 5th, 32. 2 to the 6. Oh, 2 to the 6, 64. 2 to the 7, 128. 2 to the 8, what? 256, right? Yeah, so you can keep going. Okay, and oh, I know this is negative 5, 49, and 128. So 5, 49, and 28. Is that what? Oh, 128. So I missed that. Okay, 128. 31360. 31360. Yes, so the y-intercept is 0, comma, negative 31360. Okay? It's okay. It's a big number, but that's okay. Next, you want to figure out the leading coefficient. Leading coefficient is you look at the leading coefficient of each factor. The 5 stays here, and the coefficient of x, do you see is 1, and you square it. Coefficient of x, 2, you see the square, and coefficient of x is 3, but it's to the 7. Okay, so the y-intercept is you look at the constant term of each factor, but the leading coefficient, you look at the coefficient of x in each factor. And in this case, you don't need to calculate what this giant number is. We just care about whether it's positive or negative. It's positive, so you start with the right upper corner. So our review formula, I gave you these steps. So read the step to find the polynomial functions and the step to solve polynomial inequalities. Okay, so review those. Okay, so yeah, if the leading coefficient is positive, you start with the right upper corner. If the leading coefficient is negative, then you start with the right lower corner. Okay, so real number line and x-axis, y-axis, plot the x-intercept. They don't have to be the exact squid scale, okay? You just want to make your graph very beautiful. So I know 7 is the largest number, so put the 7 here. And then I know 2/3 is another number. So you don't have to put the 2/3 to be close to 0. No, you don't need to do that. Okay? They don't have to be the good scale. So you can just make your graph pretty. Okay, so -1/2, I put it here. Okay? And the y-intercept 0, -31360. Okay, just put a dot there. So start with right upper corner. And when you reach 7, then you look at 7. 7 is the factor x minus 7. Do you see the multiplicity is 2? 2 is even, so we bounce. Okay? And then 2/3, where is 2/3? Here. It corresponds to the factor 3x minus 2. And the multiplicity is 7, so add, you cross. Great, yeah, we cross and we can connect the y-intercept too. And then the -1/2 is right here. It corresponds to the factor 2x plus 1. Do you see the multiplicity is 2? So it's even, we bounce off. So if you want to draw the picture better, it's very smooth. So you can make it smoother. So bounce, cross, and bounce again. Then this is the picture. And then read the problem carefully. You show x-intercept. Yeah, we did. Y-intercept. Yes, we did. And behavior. Don't forget that. And behavior. See? X to the right side is infinity. And y goes up. Up is infinity. And how about the left side? X goes to the left side is minus infinity. And y goes to down. Down is minus infinity. So this is how you answer the problem. And make sure you show every steps. I grade your quiz. I realize some of you missed some steps. So please make sure you include all the steps. So if you finished this problem, could you type 10 in the chat? Thank you. Oh, only 3 of you with me. Thank you for staying with me. Okay, we only have 1 problem left. Awesome. Yes. Okay. This is polynomial inequality, or you can say inequality with rational expressions. They work similar, right? So first of all, we want to find critical number. So critical number is we set each factor equal to 0. And so we have 3x plus 1 set it equal to 0, x minus 4 set it equal to 0. The denominator factors 5x minus 2 set it equal to 0, and 2x minus 1 set it equal to 0. And then we solve for x. So subtract 1 and divide it by 3. We get x equals minus 1/3. And then here we add 4 on both sides. So we get x is 4. And here we have add 2. We get 5x equals to 2 divided by 5. X equals 2/5. And here we add 1. 2x is 1 divided by 2. X equals 1/2. So we get 4 numbers, 4 critical numbers. So here, like I would say the main difference between last problem and this problem, you find critical numbers. like the x-intercept, but you don't have to find the y-intercept in this problem. Okay, but you need to find the leading coefficient. So leading coefficient is you collect all the coefficient of x in each factor. So upstairs 3 square, and then here 1x, so 1 to the power 1, and then downstairs 5x, so coefficient is 5, times 2x cubed, so 2 cubed. So you find the coefficient of x for each factor, and don't forget the exponent. And here we only care whether it's positive or negative. If it's positive, we start with the right upper corner. Okay? So you draw the real number line, and you want to plot those numbers. Let's see. Those 4 numbers, which one is the biggest? 4 is the biggest. And then you are talking about, okay, 1/2 is like 0.5, right? 2/5 is like 0.4. So 0.5 is bigger. So 1/2 is bigger. And then, where is my line? Oh, I accidentally erased it. Okay. So, and then that number is 2/5. The scale don't have to be accurate. Okay, we just sketch. And then the next number minus 1/3. Okay, so I just put them like equal size. And now you're gonna put solid circle or open circle. So I want to remind you here, you see my mouse? Okay, we move all the terms to the left, and so the right hand side is 0. We were given the right hand side is 0 and factor completely. We were given the problem is already factor completely. So don't multiply out. We want to factor, okay? So don't multiply out. You're doing the reverse direction. We want factor, okay? So don't go back. That end. Okay. So if there are fractions, yeah, combine them into a single fraction. So actually, we already factor completely. And set each factor equal to 0 and solve for x to find the critical numbers. Yes. Plot those values on the real number line. Yes, we did. So you look at the sign. If it's greater or equal or less than or equal, if you see that equal sign, you draw closed circle when you have polynomial. But if you have a fraction, you draw closed circle on the numerator roots because your numerator could be 0. But draw open circle on the denominator roots because your denominator cannot be 0. And if you have less than or greater than, then you don't have the equal sign, you draw open circle for all the critical values. Okay, therefore, numerator, what are the numerator? See, these two numbers are the numerator. Roots. So you put solid circle. And these two numbers are the denominator roots. And you put open circle. Now, leading coefficient positive, you start with the right upper corner. 4. Okay, let's see. 4. Where is 4? 4 corresponds to factor x minus 4. Do you see the multiplicity is 1 is odd? So you cross. And then 1/2. Where's 1/2? Oh, here. It corresponds to the factor 2x minus 1. The multiplicity is 3 odd. So we cross. 2/5 corresponds to the factor 5x minus 2. The multiplicity is 1 odd. So we cross. Minus 1/3 corresponds to 3x plus 1. Multiplicity is 2 even. We bounce off. See? We are looking for less than or equal to 0. Less than or equal to 0. Less than. See? Less than. Under the line. Okay, now let's see. We get minus infinity to, we actually include this number because it's the solid circle, we include this number. So you can keep going until you reach 2/5. and open circle, so parentheses, union 1/2 to 4, and we include a 4, so brackets. So this is the answer. Okay, and this is the answer of the last problem. If you can understand, could you type 11 in the chat? Great. So we have finished all the problems on the practice exam. Do you have other questions or like on your homework or on the class notes? Any problem, any questions? Do you have any questions to ask me? No? Okay. Thank you. How about other students? Are you okay? Christian? Okay. All right. Make sure you don't have any questions anymore. Are you good? So you solved all the problems on the practice exams and no more questions? And don't forget, if you have questions, feel free to come to ask me. You can come to my office hours. If you're not available during my office hours, you can always email me. Will we be counted off if we do include the other points such as minus infinity? Oh, you won't be counted off because minus infinity to minus 1/3, as long as you put brackets, then that means you include that number. Okay, so if you put something like this is okay. That means you include that number. Yeah. Okay, very good questions. Okay, good. I know it's a long time. I'm glad that you can stay, and I hope this solves all the problems, and I hope you can do well on the exam. Yeah, if you have questions, just feel free to come to see me or email me. Have a good night. I will see you tomorrow. We'll go over the quiz and quiz solution, quiz mistakes tomorrow. Bye. Have a good night.